Hey, so this series we're going to do on logs, and I think there's about three different types of questions you could get. So the first one is our standard evaluating logs, so we'll go through them. The next is our log graphs, so having a log on the vertical or a log on the horizontal and the vertical, and looking at exponential, decay, and growth functions. And very finally, I'll just quickly go over the graphs, which are very similar to the graphs from the functions as well. It's the exact same rules, but I'll go over one of them too. So the three big ones really that are new to this are your exponential growth, decay, and your graphs, and evaluating logs. So before we start on the first one here, let's just quickly go over our rules of logs. Get my pen. Okay, so if I've got a log, let's say I've got, log 3, 6, and I'm going to take away log 3, 2. Taking away logs, I can divide the argument. Okay, so this will become log 3, 6 over 2. If I am adding my logs, I can multiply the argument. That becomes 12. And the last rule you want to know is if I've got, say, 2 log 3 to the 6, I can rewrite that as log 3, 6 squared. So I can bring up this number to the front. Okay, so it's very similar to your exponential, not your exponential, your indices rules. So remember, if we had like x to the 5 divided by x to the 3, that would give me x to the 2. So the divide and the takeaway, 5 take away 3, still very much linked in. Same with this, if I had x to the 4 multiplied by x to the 5, I would have x to the 9. Add the indices when I multiply them. Add, multiply. And for this, very similar to the power rule, where you're looking at, say x to the 2 cubed, you've ended up with x to the 6. Okay, so it's the power rule still. So this is like a multiply, isn't it? It's like 2 times the log, and here we're multiplying the powers. Okay. Also, sorry if I sound a wee bit hoarse. I've had a little bit of man flu. I don't feel tip top, but anyway. So that's a bit rundown on our rules. 3 marks for these. I think the log section is an excellent section to get some good marks because it's technical. It's higher work, so you're getting some good points. Unlike, say, maybe the straight line or integration, where there's aspects where you only get 1 mark for quite a lot of working. So there's excellent marks to be had here if you remember your rules. Okay, so let's start off with this then. First thing I would say, this one, is let's move our 2 up to the top. So let's start off with log 3, 6 squared, take away log 3 to the 4. Then I'm doing a take away, so that means I'm going to divide my arguments. Fantastic. So that gives me log base 3, 36 over 4, which is the same as log 3 to the 9. Now, what does that give as well? I would also like this chance to maybe mention, I always write down the side of my page, log base 10, 100 equals 2. Okay, just to remind me what I'm doing with logs. And you can think of logs as a little bit of a time machine. Okay, it's saying, if I keep multiplying something by 10, how long until I get to 100? 10 times 10 times 10 times 10, this is the final answer. How long does it take to get there? So if I've got a base 10, how long till I get to 100? Well, it's going to be 2 turns, because 10 times 10. And the way I kind of visualize that in my head is I say, okay, well, if I move this 10 over here, I'm going to end up with 10 to the power of 2 equals 100. So when I look at this, to me that's saying 3 to the power of what gives me 9. So the answer is just 2, which again, I could move my little 3 over here, and that would be 3 to the power of 2 equals 9. That's how I picture it in my head. The proper mathematical way to picture it would be to rearrange this to say that if you rearrange it, you've got 100 is equal to 10 to the power of 2. So see the base for my exponential function, and the log stays the same. And this is saying, well, the answer is 100, the power is 2. Yeah, but in my head, quickly, that's kind of what I imagine. Just put my 10 over here and saying 10 to the power of 2 is So that's a very quick start to logs, and I hope you see that if you get this question, it is quite straightforward actually. So same again, they've tried to make it look a bit more complicated now though, because they've thrown in an x plus 5 here, but let's just do the same again. So I've got log 6x, now I'm adding these two together, so that means I can multiply. So that's going to be x plus 5, and that is equal to 2. So all I've done there is multiply these terms. Because I'm adding them, I can multiply the arguments. Brilliant. So suppose I could multiply the bracket out. So the x squared plus 5x, keep that in a little bracket. Excellent. And then what is this saying then? If I think on what I just did here, how can I rewrite this to something that I could solve? Well, it's saying that x squared plus 5x has to be equal to 6 to the power of 2. If I move my 6 over here, yeah. So that's the same then as x squared plus 5x being equal to 36. Looks a lot like a trinomial. Take away 36, I'm left with 0. Yeah. So now you're thinking, okay, well, how can I possibly solve this one? Well, we're just looking for numbers that adds to the 5 and multiplies 36. So this one actually didn't jump out at me right away. Maybe you were the same. But if you're not sure, just go through your factors of 36. So 1 times 36, 2 times 18, 3 times 12, and up, there we go, the 4 and the 9. That looks good, doesn't it? So it doesn't always jump out, but just be systematic with your factors, okay? Get good at factorising. The minute you're seeing a trinomial, sum with the power of 2, you're thinking it's going to be factorising, yeah? If it's not a trinomial, it might be a common factor, okay? But factorising, common factor, trinomial, get used to that. So I've got 4 and 9. So how can I write that then? Let's say will be x must be plus the 9 and take away the 4, because that is going to add up to 5. So I've got two answers. I've got x is negative 9 and I've got x is 4. And then we just discount the negative. We can't do log of a negative, so our answer is 4. And if you want to just think about that for a little second, let's think about how pardon me, the log graph is going to look. Okay. It's going to come through here. So I'll come through at 1, 0, and do that now. If we've got negative, if we get x is 4, so x is 4 is going to be over here, we can have an answer, absolutely. But negative 9, that's way over out here, isn't it? So we're nowhere near the graph, are we? We're not on our graph. So for that one, we can't have a solve. That's not going to work. Right? Other log graphs that we manipulated would be fine, but that particular log graph, nope, it's just a standard log, so we can't do that. We need it to be flipped over for that one to work. So yeah, you'll find that you might have to discount one of your answers as well. Okay, so just invalid, and you're left with the 4. I think we've got time for just one more, hopefully. So I'll start this off. I'll pause it and start it off to save some time. Okay, so just multiplying together these two terms, and not forgetting the 2 can go up here. So that's a nice easy one, isn't it? That's my favourite. There we go. 25 times 4 is 100. So 10 to the power of what is 100? 2. And the next one, so this is a great question. I'll try to take my time with this. So similar to what we did last time. So let's start with that then. So we'll do our log rules where we're going to divide this time because we've got a takeaway. So right away we're getting a mark. Yeah, we've done our rule. And like, it looks complicated, doesn't it? But all we're doing is rearranging again. So I'm saying 2 to the power of 5 is going to have to equal 7x take away 2 over 3. Same again, just moving this 2 over. 2 to the power of 5 has to equal the argument. Let's do 2 to the power of 5, so that'll be 32. And then to get rid of this 3, we're dividing by 3 on this side, so I'll times by 3. So that's going to give me 96. Get it all onto one side, be 98. So 98 divided by 7, just be 1, carry the 2 and 4. So x is going to be 14. So exactly the same as the other ones, but just a slightly more confusing argument to play about with. So remember this, you're multiplying through by the 3. We do BODMAS in reverse to rearrange these. And we do BODMAS in reverse. I don't move this first, the takeaway. I move the 3 because this is in our bracket. So we do the divide before we do the bracket. And then that's just a nice, we've been doing them since, for second year pretty much. But don't be confused. It looks confusing, it's not. So just keep your cool, apply your rule. Yeah, hope that's helpful. Cheers.